Okay folks, this is a guide to show you how to write a strategy for your controlled assessment investigation. We're going to kick off by looking at Strand Sa, but before I do so, I'd like to remind you that for any strand you must cover everything in the lower mark columns before you can score anything in the higher mark columns, and this applies right up to the 7-8 mark column. Now, one of the main things you need to do in Strand Sa is make a prediction. But before you can make a good prediction, you've got to remind yourself of the relevant science. So you need to do some research. You need to do some research from your textbook, from the internet, from your exercise books, and remind yourself of the relevant scientific vocabulary. You need to remind yourself of the relevant background science. The other thing you need to make sure throughout the whole of your report is that the report is set out in a logical order and you're using relevant spelling, punctuation, grammar in order to score highly in Strand Sa. Okay, let's move on to the higher marks for Strand Sa. Now this strand, it's all about you recognizing the relevant factors to your investigation and talking about the relevant scientific knowledge. So what do we actually mean by that? Okay, let's think about an investigation where you are testing how quickly you can boil water in a beaker over a bunsen burner. The relevant factors: the starting temperature of your water, the volume of the water in your beaker, whether there's any impurities like salt in the water, and most importantly, what type of Bunsen burner flame you use. Now let's say you form a hypothesis where you propose that a blue flame will boil the water quicker than the yellow safety flame. You've got to give the relevant science. So what you need to say is that to get to blue flame, you need to open the air hole. This selects more oxygen combined with the methane gas. So the methane gas undergoes more efficient combustion. This achieves a higher temperature and therefore the water boils more quickly. The other thing you need to do for Strand Sa is you need to make a quantitative prediction. So what do we mean by quantitative prediction? It means that you either predict what's happening by sketching out a graph, and again you can use some research, but you must reference where your ideas are coming from. Or alternatively, let's say you're reacting an acid with an alkali. You're carrying out a neutralization reaction and you're investigating how quickly reaction proceeds at different temperatures. So for a quantitative prediction, you might predict that if you double the temperature, a reaction works twice as quickly. Okay. Your report's gotta be logically sequenced. Make sure throughout your report, for every single strand, you're using subheadings. And it's a good idea in those subheadings to state what particular strand you're talking about. So in this instance, the formation of hypothesis, we're talking about Strand Sa. Okay, let's move on to the second part of the strategy, Strand Sb. Now this is about justifying the choice of experimental method, justifying your apparatus and carrying out a risk assessment. Now your report must contain a risk assessment to achieve a high score. Now to avoid a low score, you should aim to collect data for at least 6 different independent values and to carry out at least 3 repeats for each value. Now as you collect your data, it's a really good idea to sketch out a rough graph. Now, if it looks like the relationship isn't a linear one, so you're not getting a straight line, you're getting some kind of curve, now it's a good idea to extend your investigation so that you have perhaps 8 or 9 different independent values just to determine exactly where that curve goes. Okay. Let's move on to the higher marks for Strand Sb. Reports must contain a detailed method. Now, what we mean by detailed method is not writing pages and pages, but identifying the relevant variables. What's the independent variable? That's the variable that you are deliberately changing. What are the controlled variables? They're the variables that you're keeping the same to ensure a fair experiment. What's the dependent variable? That's the variable that you're measuring that forms the results to your experiment. A labelled diagram would be a good idea at this stage as well. When you're talking about the equipment, one of the most important things you can talk about is the precision of your measuring apparatus. So if we refer back to that experiment where we're boiling the water in a beaker again, you could talk about the type of thermometer you're using. Now, if you're using an ordinary analog thermometer, the precision of the thermometer is probably no better than plus or minus 1 degree Celsius, perhaps 0.5 degrees Celsius if you're lucky. But if you have access to a modern digital thermometer, the precision is much better, perhaps to the nearest 0.1 degrees Celsius, which improves the precision of your experiment. Now, most importantly in Strand Sb, you need to spend a lesson carrying out a preliminary experiment. Now, the idea of the preliminary experiment is twofold, really. Firstly, to give you an opportunity to get used to the experiment, to decide exactly what you're going to do, what works, whether you need to modify it. But secondly, and most importantly, you use your preliminary experiment to determine the range of values for your independent variable. So in other words, what's the smallest possible value you can have? What's the largest possible value you can have for your independent variable? And this is really important because particularly later on when you go on to do your graph, the wider the range of your independent variable, the more accurately you'll be able to assess the relationship which is shown by your graph. Alright, for the highest marks you need to complete a full and appropriate risk assessment. Now there's a different video altogether, a separate video altogether which talks about risk assessments, but on the next slide I will show you an example of a full risk assessment. So if we go back to that experiment where we are looking at boiling water and finding out the factors that affect the rate at which it boils, there's a number of hazards involved. And the hazards we're talking about are the Bunsen burner flame itself. People could be burnt, hair could be burnt, books could be burnt. Another hazard would be the boiling water. Students could be scalded. There's the hot apparatus. Again, students could receive burns or fires could be started. There's the glassware. The beaker might be broken. You might get a cut. There's the thermometer. A broken thermometer could cut somebody, or if it's an old-fashioned thermometer, it might contain mercury, which is poisonous. Now, in a full risk assessment, you must write down the various measures which you're using to control each hazard. So for example, if we look at the Bunsen burner flame, you must make sure that the Bunsen burner is set up in the middle of the bench. You must make sure that your work area, books, etc. are cleared away. You've got to make sure that long hair is tied back, loose clothing is somehow tucked away. You've got to make sure you're using a safety flame when you're not actually heating the water so students can see the flame, and you've got to make sure that students are concentrating and taking care throughout. You also need to wear safety goggles. Now I'm not going to go through all these measures, but you can see that for each hazard we've got the measures which we need to implement in order to control the risk. Okay, thank you for listening.